Hello everyone, welcome back to LeetCode Daily Live, where I do the daily question raw and uncut. So we have a medium today. It's called largest divisible subset. So let's see what it wants. So given a set of distinct positive integers nums, so we have a list of nums, which is actually quite short. It's only 1,000, so we can do an n square algorithm for today. All the values are a positive int basically, and all the integers are also unique, right? So return the largest subset answer, such that every pair of elements in this subset so satisfies these. So answer I and answer j. Wait, but answer has to be a subset of nums. Yeah, it has to be. Um, so okay, right. So that means like I is divisible by j, and j is divisible by I. So that depends on whether um whether the number, whether answer I is bigger than answer j or the other way around. If multiple solutions, you can return any of them. Okay, so that means this has to it has something to do with primes then, but we also can't brute force because, well, obviously, if we just try all these subset, it will be way too slow. How do we want to approach this? One idea is definitely to go from smallest to largest. But then there could be like may okay, and another thing is it could be that every subset is actually connected. So the thing I'm worried about is something like 2, 3, 6, right? So what I had in mind when I was reading the question, because 2 and 6 and 3 and 6 obviously satisfy the condition here, but actually 2 and 3 does not. So what does that mean for us? Well, I think that means that like for the subset, it's basically like a connected component. So well, because let's say we have three numbers, right? So let's say we have x, y, z. So if x is divisible by y, I'm not sure if this is the way to write it, but it's either y is divisible by x or the other way around. But yeah, let's say this means x is divisible by y. Please don't be triggered if I got it wrong. But yeah, but if y is also divisible by z, what does that mean? Is that means x is equal to ky, and y is equal to some pz, right? Where k and p are integers. So actually what that means is x is equal to kpc. So that means x is also divisible by c. So that means it is transitive, right? So if we have that in mind, I think we can just group all the numbers that are that are divisible by each other together, maybe. But then it has to be one direction, because well, if you look at the 2, 3, 6 case, well 6 is divisible by 2, but 3 is also divisible by 6 is also divisible by 3, but we can't group these together because 2 is not divisible by 3. So I think we have to we basically have to keep going up to see what is the next element we can get, and we want to find the longest path, I think. Yeah, I guess they also didn't give that many examples, but I think that's how you solve it. So let's say we have more stuff, right? So we can always use 2, 3, 4, 6, 8, 12. That's a good example. So when we look at 2, we want to find the next number that is a multiple of itself, right? So we can just check, and we got 4 here, and then for 3, well, we can find 6. And then like we look at 4, we can find 8 here, and then for 6 we can find 12. So what is the what is the longest path here? Well, it would be um it would be either 2, 4, 8 or 3, 6, 12, right? So like we just have to find the group that has the longest path, and then we can work like either backwards or forwards. I think. Yeah. Also, how what is the longest path we can make? And like for example, like do we want to connect something like 2 and 6 together? Perhaps like is there a case where we actually want to do that? Um. Hmm. Maybe if we have like 18, 24, 30. Yeah, in that case, would we wait? So if we keep looking, like for 12, it would be connected to like 24. Um, hmm. Yeah, that's actually a good question. Like is picking the smallest multiple always the best way to go? Cause like, what if? Yeah, what maybe we have to like connect everything. Maybe. Um. Is that true? Um. Well, like because the bound is quite small, we actually can like connect everything. So like for example for 2, we don't just connect to 4, like we can also connect to 6, we can connect to 8. So like we can do something like this, right? And then like so we can get like 2, 6, 12, 24. Like let's say we don't have 3. Well, actually like 2, 6, 12, 24 is the biggest. So like in this case, we don't actually want 2 to be connected to 4. Yeah, so we might have to like actually connect to everything then. Or is there a better way to do this? Like other than making this a graph thing? Um hmm. Yeah. Well, but like I think like when we try 4 and we see that 4 doesn't work, well, like 4 is going to give you some answer, right? Obviously. Um yeah, so 4 is going to give you some answer. Yeah, maybe we can do something recursive then. So like let's say like we have like the same stuff. Um so 2 to 4. So we see that like 4 works, right? But then like for the next numbers that we look at, um it has to be it has to be like a multiple of 4, right? Wait, is that true? Because we are following this path. Like, is there a case where like A connects to B, uh, and like wait, actually A connects to B means that like B is a B is a multiple of A, right? Um, and if B connects to C, that means like C is a multiple of B, and therefore like it will be a multiple of like every single stuff before that. But is there a case where it doesn't have to follow this case? I don't think so, right? Yeah, I don't think so. So that means like when we look at 4, we just want to like find the longest path it can make. Like connecting is like it well it is multiples. So like so you want to try like connecting to 8. And then like you want to try connecting to um well like when we connect to 8, we can also connect to like 24, and then like you can't connect anymore. But then it doesn't stop there for 4, so we want to keep connecting. But like what we can do is like let's say for 24 it is the base case, right? So I guess it is maybe we need like some dynamic programming here. So like for 24 we can't make any, like we can't make a path longer. So like we return 1 here, And then for 8, well, it can't connect to any more stuff as well. So the longest, like the longest path will contain 2 elements for 8. So like I think like we can just slowly evaluate like that. Um yeah, but then we also want to remember like because at the end we have to return the actual subset, right? So we want to keep track of like for 8, uh like forming 2 elements is the largest, right? But what does it connect to that actually gets at? Well, it connects to 24, so we have to like store the index of 24 as well, which is just write 24 for now, and like this will be none, obviously. But then for 4, well, we have other options as well, right? Like for 4, we can see that well, 12 also works, and well, like again, it connects to this, but we have evaluated for 24. So like we have this cached answer, so we can just go back straight away. So I guess like if we do this, it's going to be n squared. And then like if we also store all the like the best solution, we can also find the path. So like I guess at the end, we just want to find the longest path, right? So like we want to find the number with the largest number here, and then we just want to like start from there, and then like we just keep moving forwards and like get all the numbers and return it. Yeah, I think this is gonna work. It's probably gonna take a longer time to actually code this up because like this is not too easy to code up. But let's see. We'll code it up for now. We'll code up first. So first thing, of course, we want to sort our nums list, and then we want a DP. So what do we want in the DP? Well, I guess like we have the next element, so we'll set all of them to none for now. We'll also set n to be a length of nums. So range n. And then we have the longest path. We'll call it like largest size maybe. So we'll set it as 0 for all of them for now. Well, wait, actually, like technically, every number. Wait, actually, no. Actually, if we haven't evaluated it, we want to set it to some stop so we know that we haven't evaluated that number yet. So let's do something like this, and then maybe we want to do this recursively. So we'll write a function maybe. So get largest size. Like for some number, so it will be number, and then like we don't actually have to return anything. Like we can just put the answer in our DP array on top, and we can just do for I in range n. So if largest size of I is equal to -1, that means like we haven't evaluated that number yet. So we are going to evaluate for that number. Maybe one index instead. Maybe that'll be a bit better. So let's do index. And then what do we do after? So after we want to get the max size, so that's going to be max of largest size, and we want to find the let's write some comment first so we know what to do. So we want to find element with larger size, and then we want to work out the path for that largest size of sets, and then we can just return it at the end, right? I guess we can code this up first, and then we can work out the largest size one, because like maybe that's technically a bit trickier. We can code up the other stuff first for sure though. So find element with largest size. So this one again, we just want to loop through. So if largest size of I is equal to what is it equal to max size, then we want to set that, so largest size element, so we want to set that to be our first element, right? And then like we can obviously break through this loop, we don't have to go through it anymore. So after we got this largest size, we can just do like wait, what can we do? Maybe like answer, yeah, because like in the question they called it answer as well, so like we can for sure just do answer. So we want to put the element in first, and then now while, so next element of I guess we want an I as well, maybe, like to keep track of. Actually, we don't. We just do something like so the next element of the last element in answer. So that's like the current element that we are looking at, right? So like we can just do that. We get the next element for that. If it is not none, we want to like keep getting those numbers, right? So we can do answer append answer minus one, like the next element for it. And until like the next element is like obviously none, so it can't go any further, then we just want to return like the answer list, right? So now we just have to code up the get largest size thing. So what we want is I think like for the, yeah, because like we are doing this recursively, we can have the answer, so cur largest cur, like the current next element for the largest like path. So like we can keep track of those things. We'll set it as none for now for this. And current largest, we'll set it as 1, I think. Yeah, we'll set it as 1. And so for j in range, so we want to start from like the index plus 1. So like we are looking, so like, let's say we are looking for 4, like we're looking at 2, right? Like we want to check each of these elements, right? So basically, like if I is here, we want to check like I plus 1 all the way to the end. So we'll do something like this. So if nums j modulo our current number, which is nums index, so if it is equal to 0, then we actually want to look into it, right? So we do something like cur largest. Wait, do we want to? No. We want to check whether like we have the largest size for that number yet. So if largest size of that number is not -1, that means it is evaluated already, right? And I guess like largest size plus 1, if it is bigger than like the current largest, then well, that means like we have a better solution, right? Then what we want to do, oh yeah, also like whenever, like if you can find one element, is always going to be better than having no elements. So like basically like for the first one, it will always trigger this case. So yeah, so if we have evaluated for like nums j already, and like the largest size plus the current element is larger than the current running largest, we want to replace it. So current largest is going to be largest size j plus 1, and then current next element we'll also set it as j, and then at the end if we haven't seen any, like if we haven't seen anything, so like the current next element is still none, then we just want to return here. But before we return, like the next element, like we just keep it as none. But for the largest size of index, well, we can't find any multiple of that number afterwards, so we just set it as 1, and then like we can return. Wait, actually, we don't even need that special case, because what we can do is like we can just do current largest here, and then next element of index, like we just set it to be current next element. And well, if it has never like seen, like we want this case anyways, so we can do that. But one more thing we have to do, yeah, we don't even need return here. One more thing we have to do is if numsj hasn't been evaluated, we actually want to evaluate that first. So we want to do get largest size of j, and after we have done that, well, we can check this, right? Okay, an even better idea. We can do if largest size j is equal to -1. Well, we want to get the largest size for j first before we check whether this case works. Yeah, so we will do that. And then if largest size j, if it is, well, so yeah, we don't need that anymore, because like we know that it will be evaluated, so we can just check like straight away. If it is larger, we want to replace it. So yeah, I think that's everything. And well, unless, yeah, okay, I'm missing something. Oh, I know exactly what I'm missing. So for answer right now, we actually we're storing the index. We want to like map the index. So for index in answer, so we want to map the index back to the actual number. So nums index. Does it say like do we have to return it in order? Okay, I don't think so, but it shouldn't matter. So, but we can just do nums index. Yeah, okay. Maybe it works. Maybe it fall into some cases. No, I did not fall into any cases. Yeah, so I actually don't think there's a better solution. Yeah, I think like, yeah, like people are using like dp, yeah, dp, yeah, n squared. Yeah, so I think this is like the best solution. Maybe like if you don't do maybe if you don't do it recursively, maybe it could be a bit faster, but I'm not too fussy on that. Like we solved it. Yeah, I think this question is actually not that easy to solve. Like it has quite a lot of math stuff in it as well, and like of course it involves like DP as well. But yeah, thanks for watching, and if you have any comments, make sure to comment below. I'll read all of them, and I'll try to answer all of them as well. So yeah, thanks for watching, and I'll see you tomorrow. Bye.